And we're live. Welcome to the first ever episode of Business Focus Live. Hello, everyone. Today we're going to talk about everything about linear programming. I see some people is already online. So it's my first time doing this live stream, so do bear with me. Hello, Sophia, Rafael, or shout out na yun. Lance, Dan's also here. Kyle, Amiel, Sabrina, Gail. Hello. So for today, we'll be focusing on what linear programming is all about. So later on, we'll be discussing different aspects, what linear programming is all about, what are the examples that linear programming is used, and many more. And later on in the stream, I'll be giving an example how to use linear programming in Excel. So let's get started. And we're back. I hope you like the introduction. Anyway, so let's get started. And by the way, before we begin, so I want to appreciate everyone who's able to join in the live stream. Hope everyone's staying safe in their respective houses. Before we continue with our discussion, just want to emphasize the requirements before we continue our classes. If classes do resume. First and foremost, the requirement for your project. So our topic today will heavily focus on that. So please participate. What else? One more thing. So if any questions throughout the live stream regarding the topic or anything related to the subject, feel free to leave your comment in the chat and I'll try to get back to everyone's question. Is that okay to everyone? So I'm seeing some new people. Jerome is here. Joshua is here. Gianna is here. Who else? Chuck is here also. Rafael, Dan, Nathan is here. Good afternoon, everyone. So it's my first time doing this live stream, so it's kind of different. So anyway, so what is linear programming all about? So when you hear of linear programming, I'm sure from your previous classes, it conjures up difficulty and complexity, which is kind of true. But in reality, once you understand what linear programming is all about, then it will become easier. So linear programming is a quantitative tool or technique used by decision makers to make the best decision, especially people at the top, managers, executives, and CEO. So the higher you are in the organization, the more critical your decision making is. And linear programming can help you do that. Because in any organization, resources are limited. So you do not have an infinite resources, so you have to make do with what you have. So a good example is if your company wants to maximize profit, you want to sell as many products as you can, but the problem is with your limited resources, how can you achieve that objective? Let's see. Now, there are different components to linear programming. First is identifying the objective. So typically, the objective has two types of objectives. Sorry. Whether you maximize or you minimize. Typically, when you maximize profitability. On the other hand, when you say minimization, you typically associate with minimization of cost. Second is identifying the different constraint. When you say constraint, this pertains to the limitations or uh, limitedness of your organization. And then third is uh, identifying at least three alternative courses of action to choose from. So let me give you an example here. Oh, hello, Miss Shu. Oh, shout out then. Who else is here? Trisha is here. Wow, me is here. Dan is here. Lance is here. Nathan is here. Jamie is here. Oh, very polite tayo. Beaver on mobile. Oh, it's a nice name. Trisha is here and who's no P? Anyway, let's continue. So let's use an example to better illustrate how LP is utilized. So let's assume you're a company that produces bags and you sell two types of bags, a handbag and backpack. So question is, how do you maximize profitability in terms of how many to produce, which one to produce? Oh, hello, Niash. Moisha as well. Lloyd. Oh, I thought you were not able to join us, Lloyd. Uh, who else? Miss Capopes is here. Francis is also here. Regarding the result for the second quiz, I'm still compiling it, so I'll be sending the result hopefully by this weekend. So you can check your results. Hello, Red Chan. Nice name. Janelle is also here. Hello. Anyway, going back to the example. So you're a company, you're producing handbags and backpacks. So your objective here is to maximize profit. So how do you go about using linear programming? So let's take a look. Let's use Excel here. So the first thing you need to take into account is identifying or setting the decision variables. So for backpack, let's use BP. And then for handbag, let's represent using HB. So once you identify the decision variables, the next part is identifying your objective. So in our case, our objective is to maximize profit. So for every backpacks that you sell, you generate 100 revenue. On the other hand, for every handbag that you sell, you generate 75 pesos or dollars. Next is identifying the constraints. So as I mentioned earlier, when you talk about constraints, this pertains to the limitations of an organization. How many can they sell or how many can they produce on a particular production? So let's take a look at the first constraint. So if you take a look here, for every production of backpacks, takes about 2/7 of an hour to cut. And then for handbag, that's 1/5 on an hour. And then if you take a look here on the right side, 160 indicates the maximum allowable hours in their production. So if you take a look here, there are 4 production processes from cutting, assembly, packaging. So for each process, it has different requirements, but they all have the same number of allowable hours. Now, 160 hour is based on the assumption of 8 hours per day, 5 days a week, for 1 month. Okay. So another part in linear programming which is unique is making linear equations, as you can see here with the inequalities in the middle. So how do we translate that in linear programming? So if you recall before in our topic on spreadsheet model, this pertains to creating your parameters and your model. I'm sure everyone's already familiar. That's our next part here. So I'll copy the constraints. Okay, let me copy this. And that will be the basis of our spreadsheet model. Okay. So let me put it here beside. Oops. There you go. So the key parts in your linear programming spreadsheet model. Oh yeah, thanks for the shout out. Naka 100 subs na tayo. Thank you very much. Hi Jillian. Hi Elia. So as I mentioned again, if you have any questions, feel free to post your questions here and I'll try to answer to the best of my ability. Anyway, going back. So as I mentioned earlier, the key parts in a good spreadsheet model is implementing or developing your parameters and model. So for a parameter, here's the process in terms of the production. Here's the hours for backpacks. If you notice, we only indicate the numerical coefficient. Then here for the handbag, so 1, 5, 3, 4, 1, 7. And then the right-hand side for the available hours. It's supposed to be 160. 160. And 160. Okay. So on the right here, so we assume that's a 4 hour, 8 hours a day. 5 days a week, and that's 1 a week. Okay. And also we include the objective, which is the revenue for each BP sold, you earn 100, and then for each HB that you sell, you generate 75. So the second part is the key aspect in linear programming, the model aspects. As you can see here, it's still blank. So let's try to fill in the blanks. So the first part we need to identify is the quantity. How many of BP we need to sell, or HB we need to sell, and or that will maximize our profitability. So let's leave it blank as of the moment. So it's still 0. So the next part you need to identify is how do you maximize profitability. So in terms of if you sold 1 unit of BP and HB, how much profit will you generate? So we'll type in a function formula here. That's sum product. So you highlight 2 tables here, or 2 arrays. You can do it in any order. The first is the quantity, comma, and then highlight the revenue, comma, close parenthesis, and press enter. Now obviously you haven't produced any quantity, so you generate 0 profit. But if you produce 1 BP and 1 HB, it automatically generates the profit, which is 175. Now, if you recall in your previous topic on spreadsheet model, you can type in a different quantity and you can already determine the out profit. In this case, is 175. But our goal here is how do we maximize our resources to generate the maximum profit. So we have to add one more part under your model. So this is wherein all of your constraints comes in. Now, if you notice, we have 4 constraints. Our 4 constraints pertains to the non-negativity, meaning production can have negative number of units. Mr. Papa, we're not trying to be controversial. Thank you for the compliments, Mr. Dan. Going back. So the formulation here in your first part is key as it relates to the spreadsheet model here. Hide this. There you go. So this will be our guide later on if we've done our linear programming correctly. So the next part is copying the processes paste it here. And then here is we'll copy the type in the hours, used hour, and then on the other column is the available hours. So how do we solve for the hours used for each process? So we'll use the same function, which is sum product again. So take a look here. So type in sum product. And then again, you have to highlight two table array, at least two. So you can do it in any order. So I'll start first with quantity for BP and HB, comma. Since our process here is cutting, so we'll highlight the cutting process in your parameter. Then close parenthesis. Then press enter. So in order to highlight this, the other process, you do the same. So sum product. And then highlight quantity again. Now to make it faster, we'll lock the cell, comma, and then highlight assembly, and then close parenthesis. Now we can copy and paste the rest. So if you notice, the hours used already computed. So for producing 10 BP and HB, it only used 4.86 hours for cutting. For assembly is 16 hours, and for packaging is 3. So we can see it has not exceeded the available number of hours. Sorry, I forgot to go back to the Excel spreadsheet. So let me repeat. So for the number of hours for cutting, you just type in sum product, highlight quantity, comma, and highlight the cutting. Then close parenthesis. So if you were to take a look, the number of hours used hasn't exceeded the available hours. So the question here is, how can we maximize this? So we want to ask Excel solver to do the computation. So to do that, we go to Data tab. Instead of selecting data, we'll go to Excel solver. Let me see. Let me find that. There you go. Can everyone see the Excel solver? Yeah, I noticed I forgot to switch to the Excel spread. Sige, I'll repeat the process. Sorry for the confusion. Okay, let me go back. Okay. So let me delete the hours used. I'll start again in the model section. Okay, so as I mentioned, so after you've computed for the profit, so to solve for profit, as mentioned earlier, you type in the function formula of sum product and highlight quantity, that's 1, comma, then highlight revenue. Then close parenthesis, then you get a profit of 1,750. So the advantage of a spreadsheet model is you can see the different scenarios already. So if you produce more, it's 100 of each, you can generate more. Obviously, you can type in infinitely and can determine the profit. But the problem is, how can when we determine the maximum profit we can generate based on our limited resources in this case, our limited production capability. So we will use Excel solver to determine that. In order to determine that, we need to create another part, which is the last part, which is the process, determining the hours used for each process. So to do that, we use the same function formula again, typing some product, and highlight two table array. So the first is we'll highlight any order. So the first is quantity. Now let's lock the cell, comma, and then highlight the parameter in cutting, close parenthesis, then press enter. So you can see right away that to produce 100 units of each, the hours utilized for cutting is 48 hours, which is less than the available hours. So if we were to copy and paste the rest, we can determine if we have exceeded the available hours. So we can see in assembly, it's already exceeded. So we cannot produce 100. So let's make it 90. Okay, 90 is better. So the question is, you can do this trial and error, and it will be difficult to find out if you have exceeded or not the maximum production hours. So to be more precise, we will use Excel solver. So to do that, let's open up data tab, go to solver, change the, there you go. Can everyone see the solver? There you go. Okay. So once you have opened up Excel solver, reset all of it. So you see different aspects from the objective to maximize, changing cell, and so forth. So we'll try to fill it one by one. So to set the objective, we highlight our profit. And then we have to select whether to maximize or minimize. So in our case, it's maximization. And then by changing cell, we select the quantity. So quantity for both BP and HB. And next is subject to constraint. So this is the key part. So if you notice here on the right side, this is the constraints that we have formulated earlier. So you have to input that in your solver. So let's click add. So if you notice here, there's a left-hand side, there's inequality, and right-hand side. So we just have to follow the format. So obviously our left-hand side is the same as the one in our model under process. So let's highlight cutting is the first constraint. And then our inequality says less than equal, so we retain that. For the right-hand side, it's 160. Let's highlight the other one. So that's the first constraint. Click add. Let's do the same process for the second constraint. Our inequality is the same. And for our constraint, it's still 160. Then we have another one. So add 30, 186, less than equal. And for our constraint, it's 160. Select OK. So can anyone tell me how many constraints have we selected so far? Excel solver is the same as activating your data analysis. Instead of selecting analysis toolpath, you select solver. You choose a different option. Solver. It's the same process before. That's correct. So right now we only have 3 constraints. But in our main problem, we have 4. So can anyone tell me where's the four constraint located? Is that Mr. Kim? That's correct. That's three. Very good. Can anyone tell me where's the fourth constraint pertaining to the non-negativity? Any guesses? Yes, Miss Chu. Yes, it's not doesn't necessarily mean zero. When you say non-negative, there cannot be negative values. No, so here's the answer. So if you notice outside of the subject to constraints, look at the last part. What do you see? Yes, Miss Chu. You check the box that says unconstrained variables, non-negative. And that's your for constraint. Once you've checked that, then you have completed all your constraint. So let me go back. There you go. So once you've checked the box for non-negativity, you have completed. So the next part is to solve it. So make sure you choose the option for simplex linear programming. Once you've done that, you can click solve. So as you can see here, it's already giving you your solution. So can everyone see the outcome? So to maximize profitability, you need to produce 180 BP, which will generate 18,000. And to double check if you've done it correctly, look at the hours used under processes. So if you notice for cutting, it doesn't exceed the available hours. And for assembly, it's exactly, so it doesn't exceed. And for packaging, it doesn't exceed as well. So meaning you have met all the criteria. But the question is this the best outcome? So this is similar to what your project will be like. So can I get some feedback from the chat room? Goal set is only applicable if your variables is one variable at a time. If you notice, our problem in this scenario is multiple fold. So you have to take into account not just the hours for cutting, for assembly, as well as packaging. So it would be limited. The advantage of set goal is it's very specific to identify a particular value based on another factor. But in our case, we have multiple variables to consider. So hindi pwede ang goal set. That would be easier. So the question is how can we make it better? So is 18,000 the highest that we can generate? So I will ask the same questions in your presentation. So how can we generate a better outcome? Ms. Chu, for the track leasing, what is the main objective of the case? So there's a lag in the stream, so there's a dead silent. So now's the best time to ask. So what's the update of your preparation for your project presentation? How's it going? So discussing today is related to your project presentation. So identifying what the objective is. That's why the developing of your draft was key early on. Since you're all able to do that already, the question is how do you create the appropriate spreadsheet? So in regards to minimizing cost for Miss Chu, so you do the opposite. Instead of setting your objective to maximization, you set it to minimization. And then input all of your constraints and find out the optimal solution. I'll give you another problem on our next stream next week. Right now, I'm just giving everyone an idea how linear programming is utilized. But my question to everyone here is, how can we improve the outcome here? So our objective here is to maximize profit. So we have 4 processes from cutting, assembly, packaging. Since we only have a limited number of hours to produce, how can we improve our objective, have a better outcome, so to speak? Any ideas? So I'm going to show you the Excel spreadsheet again. So if you notice here, the problem here is we have only a fixed number of hours. But in decision making, can we change the parameter to generate a better outcome? Suggestion for Mr. Santos is work more. What do you mean work more? Utilize more hours. So in our assumption here, you already have 8 hour working hours per day for 5 days for 1 week. That's why we get 160. So how many more hours should we add? So make it 10 hours. Well, let's try that. So let's add 2 more hours. So let's make it 10 hours. So you can see here, it has generated an additional 40 hours, which seems a lot, right? So let's take a look here. So again, your profit right now is 18,000. If we were to rerun Solver, let's see what the outcome is. Sorry. Let's rerun Solver again. Let's solve. Okay. So what happened here? So if you notice, it changed the outcome already, meaning you are able to produce more BP and generate more profit. But take a look. How much profit did you improve? So from 18,000, it generated an additional 4,500. Is it a significant number of amount in terms of profit? What do you think? You could always add up more hours, but the problem here is there's a limited number of hours. But is that the main problem here? How about Nathan suggests that overtime for assembly or ship more hours to assembly. Is it assembly we need to add more? Sige, let's try that. So how many more hours would you suggest? How much more hours do we add? So right now we're at 10 hours a day for 5 days for a month. Don't produce. Yes, we can do that, not produce handbags, but you're missing the opportunity to sell your handbags. So those are decisions that you have to consider in real life. But as of the moment, based on this scenario, how can we generate more profit? Jillian, we can do that. Focus on one type of bags only. What if another manager or executive would prefer that we need to produce both? So we have to add another constraint. So we can do that. So another way of doing this, as mentioned earlier by Jerome, what if we were to add more assembly hours? So instead of 10 hours, makes it 16 hours. So two shifts. So you've generated more available hours in assembly. So if you were to rerun solver and see what happened. So we added more hours in assembly, contributed to a significant increase in production and more profit. Yes, Mr. Francis, we can decrease the hours for the other process. So how much decrease will we do for cutting and packaging? So if you notice, for cutting, we use 10 hours for 5 days for a month. So let's reduce it to 8 hours again. And rerun solver. So if you notice, did it have any impact? So you can see here that even if we reduce the available number of hours, it yielded little to no effect. So the question is, can we add more hours in our assembly? So instead of 2 hour shift, let's make it 3 shifts. Make it 24 hours. So it's maximum of 480. And let's rerun solver. Solve. See what happens here. Since we are able to add more hours, we are able to generate more profit. So take a look back here. So we started with 18,000 and now we are able to generate two folds or even three folds of profit. But my question is this the best outcome? Can we get some comments from our chat room? Yes. So creating spreadsheet is will not be difficult. The problem here is how do you come up with the different options that would yield the best possible outcome. Yes, we can do that, Jerome, decreasing the hours for cutting and packaging. Let's try that. So for cutting and packaging, it's an 8 hour work shift. So let's reduce it to 4 hours. Half of that. Okay, let's run solver again. So I reduced the working hours for what happened here. The production shifted from BP to HB, and it also reduced the profitability significantly. So should we reduce the hours for cutting and packaging? So let's return it to 8 hours. Run solver again. Click solve. So have we come up with the best possible outcome? So what do you think? Oh, is everyone still here? So to sum up, the final out the best possible outcome is by adding more hours in assembly, actually maximizing it to a 3 hour 3 shifts, 8 hour per shift. So for 24 hours, it's grinding continuously for 5 days for a month. And for cutting and packaging, we optimize it by maintaining an 8 hour working day for 5 days for a month. That's how you would utilize Excel spreadsheet using Excel solver. Now, in our next live stream, I'll show you different examples on how to utilize uh, Excel solver. I'll be sending you different examples so that you can practice at home, and then once we resume, you can do it live. Okay, so any questions so far? See some feedback? Yes, Miss Chu. Technically, it's a trial and error aspect. That's why it's called model building. But you narrow it down already based on analysis of your data. Looking at the number of available hours, what can you do? Can you increase it, decrease it, change parameter outcome? Actually, can ask, is just the number of hours can you add to improve the outcome? Yes, that's correct. We did that, Mr. Santos. We added more hours for assembly and reduced the, not necessarily reduce, but maintain the hours for cutting and packaging. But is there another way to improve the outcome? Should there is? Yes, Miss Capopes. Technically, it's a trial and error. It's okay. Oh, how about the rest? Any questions so far? So the key is analyzing the outcome of your spreadsheet. So looking at the data, but I think there's one more we can do to improve the outcome. So here's an idea. What if we were to combine processes? Would it improve the outcome? Reduce? We don't know, so we can change, we can do that. We already have an example here. So here in another example, shift here. There you go. So here if I can add another spreadsheet, and if you were to notice, I've already combined the cutting and packaging process. And But in my assembly, I've only maximized it to 16 hours a shift. So let's make it to 24 hours. See what's the outcome. Reset all of this. Objective, quantity, then the constraint, then click solve. So combining the process, did it yield a better outcome? Not necessary. It already generated 35,000. So separating the processes would be ideal, and increasing more assembly working hours. Yes, you can do that, Ms. Kapopes. So choose an item that is more profitable. Now again, that's still subjective and depends on the requirements. If you suggest that you just produce on one item compared to the other, you could do that. But what if a decision maker requires that you produce both? So what do? So you have to add another constraint. But based on our problem here, we could focus on producing more on BP rather than produce HB. See other questions? How will you if it's maximized already? As mentioned, if you utilize LP or solver, once you click solve, it will provide you the best possible outcome based on the parameters and constraints that you have provided. Yes, the constraints are given on a particular problem, and that's one of the requirements for linear programming. The objectives has to be clear and given, as well as your constraints. And actually, my next topic is to discuss on special cases that occur in linear programming. And one of the cases that do occur is that more than one optimal solution can occur, which is can be considered a positive or a negative, depending how you look at it. A positive meaning you have more than one option. But the problem is if you have too many options, it's difficult to choose which one is the best one. Second case that occur in LP is, I have a cheat sheet here, infeasibility. When you talk of infeasibility, there's no feasible solution, meaning there are two possible problems. You have too many constraints, or the constraint that is provided is too unrealistic. So changing one of them could improve the outcome. And third and final case is unboundedness. When you say unbounded, meaning there's an infinite number of solutions. So similar to the first case, the alternate optimal solution, there's too many, so you don't know which one to choose. So that can occur in linear programming. That's why it's important to have a clear, defined objective and constraints. Setting your constraint that is realistic. Let's see the other questions. So the constraints are given problem, like produce more handbags. Yes, Miss Capopes. So based on our case here, it's suggesting that we produce more on handbags. Is it handbag? Let me check. On that, it's opposite. Produce more backpack rather than produce handbags. Now, obviously, based on the model, it's telling you one thing, but the other day you have to make the decision, live with the decision. If you were to hire or fire people, stop production on one production line over the other. Outsourcing is an option, but again, you have to take into account the cost involved in it. So there are a lot of or different solutions. Just have to open to the possibility. So it's a good option, Mr. Santos. Uh, you can always search online in YouTube, but they're more technical when you talk of linear programming. They only discuss to you the formulation part, similar how you took your class in your MGT side. So there are a lot of channels that do discuss that. So I'm providing one so that it could help students like you. Maybe could find a better scheduling for next week. Any other questions? And scheduling is a problem for your online classes. And we don't even know what will happen with our quarantine situation. Will it be extended or will it end by mid-April? So just remember, in linear programming, setting your objective and constraint is key. So that when you create your spreadsheet model later on, it won't be as difficult. Yes, Mr. Santos, the constraints are given. Yes, it will be given. And like in any situation, like in your assignment, in your project, in real life situation, the problem is, or the constraint is, you have limited number of resources in terms of number of hours you could work. Now, if you notice in our problem, we can only maximize it to 24 hours a day. So you can add 25, 26 hours, but that's unrealistic because in a day, you only have 24 hours. So to add more hours is unrealistic. Yes, I will send the file. Uh, I will send an Excel file containing the other examples so we can discuss it in our next live stream. Any more question? Time to fly so fast. It's already an hour of stream. By the way, how are you receiving me? Am I being seen clearly or is there any buffering? I don't know how the rest are seeing me. By the way, do you like my gray background? It's just plain water. How about the rest? Oh, that's good to hear, Grant. Oh, that's good to hear, Sabrina, Elia, Audrey, Raphael, Lance. Thank you. So, I think that's about it. Unless you have any more questions. Yes, Elia, I'm using green screen. What do you mean file missed you? You can rewatch the stream once it's uploaded. Yes, Mr. Lim, it's green screen. I had to set it up. Thank you very much. I had difficulty preparing for this one. Last night was a very difficult situation in terms of setting up. I'm using another software that talks to YouTube and so forth and so forth. So it's a very interesting experience, so, to say the least. Okay, thank you very much. I think we'll end our stream here. So thank you for your participation and good news. So we've reached 100 subscribers. Yes, I'll try to upload more examples in our next streams. Is that you, Mr. Kim? I can't read Korean. Yeah, I'll message everyone. I'll check who's the 100 subscriber. Oh, thank you for the compliment, Miss Panganiban. Okay, so I'll see you next week. So thank you, Sabrina, Niash, Dan, Elia. We'll try to make more time once I'm familiar in the setup. So I was afraid that I'll have difficulty in our stream, especially with the connection. Okay, thank you. See you next stream. Yes, it's water. Yes, Miss Trisha, you can still consult. Either email me or you can ask it me during the stream. So as long as it's related to the subject, there will be no problem. Yes, the stream will be uploaded once the stream is finished. So it's an advantage for everyone. So for those who are not able to watch the stream or participate, you can watch it again later. And for the rest also, so if there are any clarifications or questions that you were not able to follow, you can always go back to it later. That's why I chose the live stream as a tool. Okay, that's it. Thank you. Bye. Yes, you can watch it again, Dan.